In this problem, we're going to explain when we multiply a number by 10, why we shift all the digits one place to the left. Or sometimes we tell students, then you can just add a 0. If it's a whole number times 10, we can add a 0 to the end of the number. And we need to explain to them why this works. So when we explain, we need to explain why we shift all the digits or each digit one place to the left. So that's what we need to explain, why shifting the digits. So what we do is we can explain digit by digit. So if I write this down, 32 has 2 ones and 3 tens. Now if we multiply by 10, and which means we have 10 copies of 32, and we can start from the tens, and notice also, so this is the original number 32, and after we multiply by 10, now we start from the 3 tens, and each 10 times 10 we're gonna get 100. So that's the place value we learned. And again, if we have 10 bundles of 10 toothpicks, and that's going to be 100, and 3 bundles of 10 will become 3 bundles of hundreds. So that's tens, ones, and hundreds. So after we multiply by 10, I guess in my explanation I started with 2. Okay, so 10, first of all, 10 times 32 means we have 10 copies of 32 or 10 groups of 32. Separately will be 10 groups of 2 ones and 10 groups of 3 tens. So that's why we're doing it separately. And what I did was the 10 times 3 tens, which gives us 30 tens. And 30 tens, and that is equal to 300. So now 3 tens becomes 3 hundreds. And notice that this digit is shifted one place to the left. Similarly, 2 ones, if you have 2 individual toothpicks, and after we times by 10, each one toothpick becomes a bundle of 10. So that's why it becomes 2 bundles of 10. So the 2 is also shifted from the ones place to the tens place. So this way we can explain why we're shifting each digit. And after we shift all the digits, there's nothing left in the ones place. So of course we have to put a 0 there. So that's why sometimes we say adding a 0.